Hello, come in, and please close the door softly behind you. The rain is pouring down, and this is a story that's waited patiently to be heard. It is a little strange, but then so much of early human history is odd. We're odd creatures. Hello, and welcome. Let me pour you a drink. I'm Mith, and this is the History Sanctuary. Please sit. Take a moment to settle in. Whether you're here to learn something new, to keep quiet company while you work, or to let the past gently carry you toward sleep, you've found the right place. Here, history is shared slowly, thoughtfully, not as a string of dates to remember, but as the lives of real people in real places, people who shaped the world in ways that have mostly faded from memory. Everything you'll hear comes from careful research, from genuine discoveries, from the work of dedicated historians, researchers, and scientists. And this voice is simply mine, not artificial, not generated, just me in a quiet library, turning pages by firelight and passing those stories along. If you're planning to drift off tonight, please consider liking, following, or leaving a comment before sleep finds you. The algorithm isn't known for its gentle reminders, but I'll be glad to be able to welcome you back. As for those staying a while longer, welcome to the archive. The kettle is warm, there's a fire roaring in the fireplace, and there are stories waiting for us. I want to tell you about a discovery that should have been impossible. In 2010, scientists announced that they had found an entirely new species of human being, a people who had walked this earth for hundreds of thousands of years, who had ranged across half a continent, who had met our other ancestors, lived alongside them, and left a mark in our blood. And the entire physical evidence that proved their existence was a single finger bone, the tip of a child's little finger, no bigger than your thumbnail. From that, just that, scientists read an entire genome. And what the genome told them shook the field of human evolution to its very foundations. This is the story of the Denisovans, and it gets stranger with every passing year. In the Altai Mountains of southern Siberia, there is a cave named after a hermit. An 18th century Russian monk named Dionysi in Russian, once lived there in solitude, and so the place became known simply as Denisova Cave. It's a cold, quiet place, 3 chambers of limestone above a river, carved into a ridge that looks out over an ancient forest. People have been finding things there for decades: stone tools, animal bones, the remnants of long-gone lives. In 2008, Russian archaeologists digging in the cave's eastern gallery found a small bone fragment in a layer of sediment. It was the finger bone of a juvenile female hominin, originally estimated to be around 50,000 years old, later revised to be between 76,000 and 51,000 years ago. It was so small, so unassuming, that at first no one was quite sure what they had. It didn't look obviously different from a modern human finger bone. The archaeologists sent it to Svante Pabo, the same man who was revolutionizing what we knew about the Neanderthals, at the Max Planck Institute in Leipzig. What he found inside was not what anyone expected. The mitochondrial DNA extracted from the bone differed from modern humans by 385 base pairs out of approximately 16,500. For comparison, the difference between modern humans and Neanderthals is around 202 base pairs, and between modern humans and chimpanzees, around 1,462. The bone was more different from us than Neanderthal was, but not nearly as different as a chimpanzee. It sat in a strange middle ground, undeniably human, but belonging to no human line anyone had ever documented. The paper announcing the discovery ran under the headline in the Sydney Morning Herald, quote, "Giving accepted prehistory the finger," unquote. They named the new people Denisovans, after the cave. Harvard geneticist David Reich, who led the population analysis, noted the remarkable reversal of how archaeology usually works. He said, quote, "We have next to nothing in terms of bones. We don't have a skull. We have just a finger bone and a tooth. And now we have a genome. And the genome tells us a lot," end quote. A whole species discovered not from a skull or a skeleton, but from reading the chemical letters in ancient, degraded DNA. For 15 years after that discovery, the Denisovans remained almost entirely faceless. A few more fragments emerged from the same cave. Teeth so large they originally looked like cave bear molars. The teeth were enormous and unusual, unlike those of humans or Neanderthals. Their third molar resembled those of Homo habilis, or even Australopithecines, rather than a modern human. Pabo himself said, quote, "The only thing we can say is they must have been very big, or at least have big mouths," unquote. A jawbone turned up, found decades earlier in a Tibetan cave by a Buddhist monk. A tooth fragment in Laos. A jawbone dredged from the seafloor between Taiwan and China. All of them identified not by their shape, because no one knew what shape a Denisovan should be, but through protein analysis and scraps of DNA. The Denisovans were among the best known genetic mysteries in human evolution, and among the least known physical ones. We knew their code. We had almost no idea what they looked like. That changed in 2025. In 1933, a Chinese laborer working on a bridge over a river in Harbin in northeastern China found a skull. An enormous, heavy skull, thick brow ridges, a wide face, a large brain cavity, buried in the riverbank sediments. He hid it. The Japanese occupation was underway, so he wrapped it carefully, lowered it into an abandoned well on the family's property, and told no one outside his family. He kept that secret until the end of his life. Before he died, he told his grandson where it was. In 2018, the family retrieved it. In 2021, researchers named that skull Homo longi, Dragon Man, after the Dragon River region of China where it was found. It was at least 146,000 years old. Based on its massive size and distinctive features, some suspected it might be a Denisovan, but suspecting is not knowing. Getting DNA from a skull that old, that had been buried in river sediment and then hidden in a well, and then passed between hands for decades, seemed almost hopeless. Chow Mei-fu, the same scientist who had been part of the first study of the Denisovan finger bone DNA back in 2010, decided to try anyway. Rather than looking for genetic material in the bone itself, she looked into the dental plaque, the fossilized gunk on the tooth's root. She scraped 0.3 milligrams of it, less than a grain of salt. And it worked. In June 2025, 2 papers published simultaneously in Science and Cell confirmed it. Dragon Man was a Denisovan. After 15 years, the Denisovans finally had a face. Dragon Man was a large male with a wide, flat face, prominent brow ridges, a round nose, a large mouth, strong cheekbones, and a big brain. More primitive in some features than modern humans, but with a surprisingly flat lower face and eyes that would not have looked entirely alien to us. Of course, some scientists are still debating this, whether the links are close enough to call Homo longi and the Denisovans the same species, but that's just healthy science doing what science does. Challenges and questions are all part of the process. Once Dragon Man was added to the Denisovan story, something else clicked into place. Other skulls and bones from across China, fossils that had been sitting in museum collections for decades, labeled archaic human unclassified, began to be re-examined. In a study published in September 2025, remains from 6 additional sites in China, including fossils potentially as old as 1 million years, were proposed to belong to the same species as Homo longi. The Denisovans, as it turns out, were not a small, isolated pocket of people in a Siberian cave. They were a vast, continent-spanning population that had occupied Asia for perhaps 1,000,000 years. From the frozen Altai Mountains down through China, across the Tibetan Plateau, through Southeast Asia, and into the islands beyond. Their range extended from the cold, high-altitude environments of Siberia and Tibet, to which they were supremely well adapted, all the way down to the tropical islands of Southeast Asia. We simply hadn't recognized them because we didn't know what to look for. And then there's Denny. In 2018, researchers analyzed a small bone fragment from the same Denisova cave, a long bone cataloged among over 2,000 unidentified fragments, unremarkable to look at. Protein analysis confirmed it was human. DNA analysis revealed something extraordinary. It came from a girl, at least 13 years old, who had lived around 90,000 years ago, and her genome told a story no one had ever read before. Her mother was a Neanderthal. Her father was a Denisovan. Denny was, to our knowledge, the first direct hybrid between two distinct human species ever discovered. Not a population that had interbred over generations, but a single individual, the first generation child of two different kinds of people. Her Neanderthal mother's line came from the West, genetically closer to Neanderthals found in Croatia than to those from that same Siberian region. Her Denisovan father carried traces of even older Neanderthal ancestry from mixing events hundreds of generations before his own birth. Denny's existence tells us something quiet and profound. These were not separate, sealed-off worlds. The Altai Mountains in the late Pleistocene were a crossroads. Neanderthals and Denisovans did not just coexist. They recognized each other. They came together. They had children. Now, here is a part of the story that I think deserves to be told slowly. The Denisovans are gone. The last of them probably disappeared somewhere around 30,000 years ago, perhaps less. But they did not simply vanish from existence. Like the Neanderthals, they were absorbed. Their genes are still here. Up to roughly 5% of Denisovan DNA occurs in Melanesians, indigenous peoples of Australia, indigenous Filipinos, and the people of Papua New Guinea. In contrast, only about 0.2% derives from Denisovan ancestry in mainland Asians, Siberians, and Native Americans. The population that carries the most Denisovan DNA on Earth today is not who most people would guess. It's not the people of Papua New Guinea, though they carry a remarkable amount. A 2021 study discovered that the Aita Mabukan people of the Philippines carry about 30 to 40% more Denisovan ancestry than the Papua New Guinea people or indigenous Australia. They possess more Denisovan ancestry than anyone else alive on Earth today. But perhaps the most astonishing story of Denisovan survival is not in the islands. It's on the rooftop of the world. Tibetan people can survive on the Tibetan Plateau at altitudes above 4,000 meters, where the air holds 40% less oxygen than at sea level, in part because of a mutation in a gene called EPAS1. This mutation is found in 87% of Tibetans and just 9% of Han Chinese. Where did it come from? The Tibetan EPAS1 variant is almost identical to the Denisovan version. It was a Denisovan innovation inherited by the ancestors of modern Tibetans when their populations met and interbred somewhere in ancient Asia. Without that gene, without that ancient encounter between two different kinds of people, the Tibetan plateau might never have been permanently settled. The entire culture, history, and civilization of Tibet rests, in part, on a gift from a people we only discovered a few years ago from a child's fingertip. Millions of people are alive today that carry genes from a species we didn't know existed until 2010. The Denisovans were not a footnote. They were not a curiosity. They were a vast, successful, continent-wide people who shaped the world that modern humans walked into. They roamed, they crossed over water, they climbed mountains, they survived and lived with other human species. Their DNA helps some of us breathe at altitude, fight certain infections, and perhaps adapt to environments that would otherwise have been closed to us. We owe them more than we know. A finger bone, smaller than a matchstick, found in a cave in Siberia that was once home to a hermit named Denis. From that, we learned that an entire people had existed, that they had ranged across a continent for perhaps 1 million years, that they had children with Neanderthals, that their genes still help Tibetan monks breathe at altitude and still live in the blood of the people in the Philippines who have lived there since time untold. Science sometimes pulls back a curtain that you didn't even know was there. An important human cousin of ours had been gone for 30,000 years before we ever knew to look for them. I wonder what else is waiting. Come back to the sanctuary soon. There will be more stories to come and plenty of music to relax to. Don't forget to check out my soft-spoken history of the Neanderthals, too, if you haven't already. Now, if you've enjoyed sitting by the fire with me today, please do subscribe, like, and comment so that more people can find their way to our little library sanctuary. We have a lot of history to unpack, and the kettle is always